Alright, back in another chemistry class. Today we are looking at removal of hardness of water. In our previous class we talked about two types of hardness of water, temporary hardness and permanent hardness. How do we remove temporary hardness of water? It can be removed by simple boiling. Let's say we have magnesium, hydrogen, trioxocarbonate 4. Then we heat. So when we heat, there's going to be breakdown of this hydrogen, of this magnesium bicarbonate. Magnesium, hydrogen, trioxocarbonate 4. So we are going to have MgCO3 plus water plus CO2 that will be given up. So that will give us the water that is free from temporary hardness. We can also remove the temporary hardness by treatment with base. Let's say we have magnesium, HCO3. Let's use a base like calcium hydroxide. Let's use calcium hydroxide. So we are going to have MgCO3 plus CaCO3 plus H2O. So let's check. 1 magnesium, 2 hydrogen, 6 oxygen. Okay, hydrogen is now 4, 2 here, 2 here. That's 4 hydrogen, 6 oxygen, 8. Oxygen is now 8. So we put 2 here and check. 2 hydrogen, 2 hydrogen making 4. That's 4 hydrogen there. 2 carbon, 1 carbon making 2. 6 oxygen, 8. 3, 6, 8. 1 calcium, 1 calcium. So that is balanced. Solid, liquid. This is aqueous, and this is also aqueous. So we can remove temporary hardness by boiling or treatment with base. So how is the permanent hardness of water removed? Permanent hardness of water can be removed by ion exchange. The ion exchange made up of large polymer particles coupled with sodium ion as zeolite or resin. When we have sodium ion zeolite added to water that contains dipositive ion such as Fe2+. So what's going to happen is that the dipositive ion that is present in the water will displace sodium from the polymer, and then we are going to have FeZ plus Na2+. So sodium ion will be displaced from the polymer, and that will remove the hardness. That will remove the hardness of the water. Then this will be filtered off from the water. And if we are using resin, sodium, synthetic resin plus Ca2 plus. Don't forget that these are from the nitrates, chloride, or the sulfates of the hardness of permanent hard water. So the calcium 2 plus will displace the sodium. So we are going to have Car plus Na2 plus. So the solid particles will then be filtered away from the water. Okay, purification of water for municipal supply. How do we purify water for the use of the city? Metropolitan, that is the city, for human consumption, either for domestic purpose or for industrial purpose. Domestic purpose like cooking, washing, bathing, and industrial purposes like brewing, fermentation, pharmaceutical, and the likes. So the first step in purifying water from municipal supply, let's say water from dirty river or dirty ocean, the first thing is to screen. In the process of screening, you remove the coarse particles, debris. You remove debris, removal of coarse particles. That's coarse particles. Removal of coarse particles from the water, such as dead animals, that is dead animal carcass. You remove debris, that's a plant left over, tires, wood, and every dirty things, plastic deposited in the water. That is screening. The second one is aeration, that is oxidation of the ion, dissolved ion, magnesium dissolved in the water. And another purpose of aerating the water is to destroy anaerobic organisms that are surviving in the water. So take note, you oxidize the dissolved minerals in the water, and then you aerate to destroy anaerobic organisms in the water. When we talk about anaerobic organisms, we have bacteria like Clostridium botulinum that causes food poisoning. We have Clostridium tetani that causes tetanus. We also have Clostridium perfringens, which also causes food poisoning. So if they are present in water, they can survive in water that has little oxygen. So the water needed to be aerated to destroy those anaerobic organisms. Then the third one is sedimentation, using alum. You use alum to coagulate suspended particles. Using alum to coagulate suspended particles in water. Coagulate suspended soil or clay particles in the water. Soil or clay particles in the water. That's the essence of sedimentation. After those particles, after soil particle and clay particle is coagulated and settled down, the next thing is to filter. The filtration is done through sand bed. Sand bed, that is sterilized sand is used to filter the water. You make your sand bed inside a cylinder. So as the water passes through the sand, it begins to filter the water. It will hold back any suspended particle that manages to escape, that is not settled. The sand bed will filter them. It will also attach any anaerobic organism that manage to escape oxidation. It will hold them back. It will not allow them to pass through. So it filters. It also purifies the water. So take note, sand bed does not only purify and does not only filter, it also purifies the water. And when talking about disinfection, it involves the use of chlorine. Using chlorine to kill germs or waterborne disease pathogen. So in case any of those microorganism pathogens still manage to escape filtration and aeration, finally when you disinfect the water with chlorine, that's called chlorination. It will undo the matter. It will kill the pathogen that escape. Also, the potable water or water that is treated from municipal supply usually takes residue of chlorine. So residue of chlorine is to be left in the water to avoid post-contamination. What do I mean by post-contamination? After the water has been purified from the water supply factory or company or establishment, in the process of transportation, in the process of bottling, in the process of putting it in nylon, there could be contamination. That's what's regarded as post-contamination. But residue of chlorine that is left inside the water will kill any pathogen, any waterborne pathogen that manages to get into the water in the process of transportation, bottling, or storage. So that is why potable water will taste residue of chlorine. Because of that, you cannot regard that as pure water, because it's going to have dissolved chlorine residue present in it. Alright, next we are considering is solutions. Mixture of solutes and solvents is what is regarded as solution. When you talk about solute, that is the substance that is being dissolved in the solvent. The substance that is being dissolved in the solvent is regarded as solute. And when you talk about solute, it can be solid. Solute can be solid, it can be liquid, and can be gas. And when you talk about solvent, solvent is usually liquid or gas. Liquid or gas. So solute plus solvent will give us solution. Solvent can be liquid or gas. Both are regarded as fluid, whether liquid or gas. So solvent can be regarded as fluid. Then we have types of solution: homogeneous solution and heterogeneous solution. Homogeneous solution, that is a solution in which the solute dissolve entirely in the solvent. Homogeneous solution, the solute dissolve entirely in the solvent. What do I mean by entirely? It means you will not see traces of the solute in the solvent. The solute molecule will be absorbed into the solvent molecule. That is homogeneous solution. And when you talk about heterogeneous solution, in heterogeneous solution, the solute can still be seen. It's still physical in the solvent. It's still physical in the solvent. Talking about homogeneous solution. Homogeneous solution can be formed in different ways. Homogeneous solution can be formed in different ways. Homogeneous solution can be formed in different ways. Number one, we can have solid in liquid. Solid in liquid, e.g., sodium chloride, our table salt, dissolved in water. That is homogeneous. You will not see the sodium in water again unless it has reached its saturation. Secondly, we can have gas in liquid, e.g., CO2 in water. CO2 in water, that will give us carbonated drink. You can also have SO2 in water, that will give us acid water or acid rain. Also, we can have oxygen in water through aeration. Oxygen in water. The third way of forming homogeneous solution is by dissolving liquid in liquid. Liquid in liquid. We can have liquid in liquid. Liquid in liquid. E.g., spirit in water. Spirit in water. That is another homogeneous solution. Homogeneous solution. And then fourthly, we can have gas in gas. Gas in gas. That will give us homogeneous. An example is air. Don't forget that air is a mixture of gases. Air is a mixture of gases. So these are four ways whereby homogeneous solution can be formed. Heterogeneous solution. That's a solution whereby the solute does not mix entirely with the solvent. The solute does not mix entirely with the solvent. The solute is still visible to the naked eyes. For example, sand in water. Sand in water is an heterogeneous mixture. Let's talk about true and false solution. True and false solution. When we talk about a true solution, that is a solution. That's a solution in which the solute dissolves entirely in the solvent, meaning that true solution is homogeneous. True solution is homogeneous. But when you talk about false solution, in false solution, the solute does not dissolve entirely in the solvent. That is, the molecules of the solute are not totally absorbed by the molecules of the solvent. Although in false solution, the molecules of the solute are not larger enough to be seen with naked eyes. So let's look at some differences between true solution and false solution. Before we look at the differences, another name you can call false solution is colloidal solution. Colloidal solution. So we can call false solution colloidal solution. For instance, if you dissolve egg in water, fresh egg, raw egg in water, the egg might not be visible to the eyes, but you can still perceive its presence in the water. It makes the water appear slimy. So egg in water is an example of false solution, otherwise called colloidal solution. Number one difference between true solution and false solution. 1. Particles are smaller. Particles are smaller for true solution, but false solution, particles are larger. Particles are larger. Secondly, particles do not settle. Particles do not settle because they have been absorbed into the molecules of the solvent. But for false solution, particles settle. Particles settle. For instance, if you dissolve milk in water, that's an example of false solution. It will settle on standing if it is not disturbed. Thirdly, for true solution, particles pass through filter. Particles of the solute. Particles of solute pass through filter. Pass through filter. But that of a false solution, particles of solute do not pass through filter. Do not pass through filter. Do not pass through filter. Number 4, when you talk about true solution, particles pass through membrane. Particles pass through, that is, particles of the solute pass through membrane. Membrane, that is permeable membrane. While for false solution, particles do not pass through membrane. Particles do not pass through membrane. Do not pass through membrane. And lastly, when you talk about true solution, do not exhibit tyndalization. Do not exhibit tyndalization. Tyndalization. Why that of a false solution exhibits tyndalization. Exhibit tyndalization. Tyndalization. That is, if you pass through light rays through a true solution, the light rays will appear on the other side will appear on the screen without being scattered. That is for true solution. But for false solution, when you pass light rays through the solution, it will scatter the light ray on the screen at the other side. So the scattering of light rays when it passes through solution is regarded as tyndalization. Scattering of light rays when it passes through solution is regarded as tyndalization. So true solution do not exhibit tyndalization, while false solution exhibits tyndalization. Alright, before we conclude the class, we have different forms of false solution, otherwise called colloidal solution. Colloidal solution can exist in different forms. We have the solute, we have the solvent, and then the colloids that we are going to have. That is the colloidal solution. Gas in liquid. When you have gas in liquid, what will be the product? The solution will be foam. So foam or lather. So when you see your soap foaming, it produces gas in liquid. So gas in liquid will give us foam. Then liquid in gas. When we have liquid in gas, it will give us fog. Fog. That's what you see during Ramadan. That you see dropping, that form haze, that impair visibility. That is fog. When we have solid in gas, that is smoke. Smoke. That is why you see carbon particles hanging around in the corner of your room, on the cobwebs in the room, in the kitchen, in the store. So we have carbon particles in gas. So solid in gas will give us smoke. Liquid in liquid will give us emulsion. Emulsion, like your paint, the paint, your emulsion paint, water paint, your oil paint is liquid in liquid. Then solid in liquid. Solid in liquid will give us what is called sol, gel, or paste. So your toothpaste is solid in liquid. When you dissolve starch in liquid, you have salt or gel. Your shampoo, your starch, your paste, your cream is solid in liquid. So in the next class, we shall be talking about solubility, the calculation. We shall talk about saturation, unsaturated, solution, and supersaturation. Till I come your way some other time, keep studying, keep learning.